So now, today's our topic is speed control of DC shunt motor. So whatever the control methods we apply speed, same methods are applicable separately exerted also. Why? Because if you see voltage equation of a both motors, both are same. There EB is equal to V minus IA RA. Of course minus brush drop is there, but brush drop is constant. It won't vary. So that is very small. That's why we neglect it. So now here we have to control the speed of the motor. As we are electrical engineers, we have to control the motor speed by using electrical terms only. That's why load is we are maintaining as constant. It is one of the assumptions. Why load we have to maintain constant is, if you vary the load, if you varying any one electrical variable, if you varying the load, we can't say because of that electrical variable only how load is varying. So to how speed is varying. To know exactly because of any variation of any one electrical variable how speeds are varying, to know that firstly we have to maintain mechanical load as constant. And another is, if you varying any variable, remaining variables we have to maintain as constant. And supply, input supply to the motor also we have to maintain constant. That is must. These three assumptions we are going to following to control the speed of the motor. Now say expression for back EMF or expression for induced EMF in case of DC motor or DC generator, which is equal to Eg. In case of generator, we are going to define with the generated induced EMF. Eg is equal to pi Zn by 60 into P by A. There number of poles, parallel paths, number of conductors are fixed. After designing the machine, it is not possible to change. That's why Eg or Eb we can say are directly proportional to Eg or Vb directly proportional to Eg or Vb is directly proportional to pi into n, flux into speed. So with this we can define n is proportional to Eb by pi. So from this n we can Eb expression we know for DC shunt motor. Eb is equal to V minus Ia Ra after neglecting brush drop. So n is proportional to V minus Ia Ra by pi. Here see we can vary the speed by using supply voltage V, IA, RA, pi. There are four variables are there in that expression, but IA should be always maintained constant. Why IA should be maintained constant? That is different. It will be maintained constant in different methods, different ways. That we'll see separately. So here, so IA should be constant means we can define n is proportional to V minus IA RA by pi. In that, by varying supply voltage will vary the speed of the motor. By varying armature resistance RA will vary the speed of the motor, and by varying flux will vary the speed. These three methods we are having to control the speed of the DC shunt motor. So variation of flux is called flux control method. Variation of flux is called a flux control method. After designing the machine, once we given supply, magnetover will come to saturation period. After saturation, it is impossible to increase the flux without changing the dimension of the magnetic core. So flux is constant means it is not possible to increase the flux. So there is a possibility to decrease the flux. That's why this method is also called flux weakening method. Field control method or flux control method is also called flux weakening method. And another method is armature resistance control method. Armature resistance will vary by connecting any one rheostat resistor in series to that. That method is called armature resistance control method. And another method is by varying supply voltage. Input supply, if you vary also, speed of the motor varies. It is proportionality varies. Now we'll see about these three methods separately. First come to flux control method. So flux control method, we take schematic diagram of DC shunt motor. Armature, supply voltage all are connected in parallel. Flux also connected in parallel. So you can say it is a shunt motor, parallel motor. Now flux only we are going to varying, that's why armature resistance kept constant, supply voltage also kept constant. That's why to the field winding we connected one resistor in series to that. Initially resistor is kept constant. Rheostat is it's a pure resistor which is available. Wound wire resistor. Wound wire means no doubt there is a mustly some inductance. So any wire wound device, some inductance will be must, but here inductance is zero. So anywhere, if anyone examiner asks in interviews, you have to say where pure wound wire resistor is available means rheostat. Why? Because that number of turns, when rheostat turns are placed on enamel sheet, not on a iron core and disc. Enamel sheet, and that too, if 5 turns, if you wounded forward means 5 turns will be wounded in reverse direction. That way inductance will be nullified. That's why you can use it as a pure resistor in some applications. So no flux is there through because of rheostat. Flux will be because of only field winding. Now, if resistance is zero, that time only field resistance is in the operation. So N is proportional to V minus IA RA. Now, if I increase the resistance, if resistance increases, what happens? ISH field current decreases. Why? Because ISH is proportional is equal to V by RSH. Supply voltage will maintain constant. So resistance increase means ISH or IF decreases. If IF decreases means what? IF is proportional to flux. So flux decreases. If flux decreases, what about speed? Speed is maintained constant. Why? Because V constant there, RA we are not varying constant. IA it will maintain itself constant. How it will maintain constant we'll see now here. See, expression for IA in case of shunt motor is nothing but what? IA is equal to V minus EB by RA. IA is equal to V minus EB by RA. Armature resistance we are not changing, so armature resistance is constant, supply voltage is constant. EB, expression for EB is proportional to what? Phi into N. So here flux is what? You are decreasing. If flux decreases means EB decreases. If flux decreasing, speed is increasing there. So if speed is increases means again EB increases. So flux decreasing, speed increasing, proportional to EB changing means EB will be maintained constant there. One time increment, one time decrement means EB is constant. So V constant, EB constant, RA constant means IA also constant. IA also constant. Like if you want to understand, like so 2 is equal to 20 minus 10 by 1. 20 minus 10 by 1 is equal to what? Always 2. It is always 2. So IA is maintained constant like this. Now here in this method speeds you are getting what? Increase or decrease speeds. If you run the motor at zero resistance, field at zero resistance, field winding connected in series rheostat is maintained zero. That speed is called rated speed. So if you increase the resistance, speed is increasing. That's why this method is used for above rated speeds applications. There is a possibility to increase the speeds here. There is no possibility to decrease the speeds. So torque is proportional to what here? Pi Ia. So flux is what here? Decreasing. Armature resistance is constant. So torque is what? Decreasing. So this type, we can say this type of method is used for variable torque or torque decrement applications. Now, what type of output powers we are producing here? So output power is proportional to output power formula is what? Output power to the motor is what? Mechanical power. Mechanical power expression is what? 2 pi nt by 60. So 2 pi by 60 is constant. So you can say output power is proportional to n into t. Output power proportional to n into t. Here what type of speeds you are getting? Above rated speeds. And what type of torques you are getting? Decreased torques. So when speed increases, output power increases. If speed is increasing, torque is decreasing. If torque decreases means output power decreases. So finally output power is not constant. That's why we can say this type of method is used for constant output power applications. This type of method is used for constant output power applications. These 3 points you have to remember here in this method. In flux control method, you can get above rated speeds, torques, variable torque applications. This type of method is used, and this type of method is used for constant output power applications. Next, come to armature resistance control method. Armature resistance control method. So now here in this method, only armature resistance we vary by connecting one rheostat in series to that. So flux is maintained constant, supply voltage maintained constant. So pi constant, V constant. I also maintained constant itself. How it maintains constant? We'll see now here. So we know expression for n is what? V minus IARA by 5. If you are increasing the armature resistance by connecting one external resistance in series to that, then if you increase what you can get, N is proportional to V minus IA into RA plus R external by pi. So finally IA numerator you see V minus V constant flux constant, IA into RA plus R external. If we increase the resistance means IA into the drop is also increases. If that increases, what speed is what decreases. Why? Because V minus V constant flux constant. So speeds decreases. That's why you can say this type of methods are used for decreased speeds applications. Decreased speeds applications. Now speeds are decreasing here. So how IA maintain constants come down? You know expression for IA is equal to V minus EB by RA for shunt motor or separately excited motor. RA here what RA resistance increasing means RA value increasing is what armature current decreases. See here, because of increment of armature resistance, armature current is decreasing, IA decreasing. You see now there, we supply voltage maintain constant. EB varies. How it EB varies is, EB is proportional to what pi into N. Here flux is what constant, but speeds are what decreasing. If speed decreasing, what EB decreases. If EB decreases means V minus EB total value increases compared to initial value. So V minus EB increases means IA increases. So if armature resistance increases, IA decreasing in the same way, because of V minus EB increment, IA maintain the constant. This is very important point. Try to listen very carefully. Try to analyze this. Like this, IA will be maintained constant. Next come to torque. Torque is proportional to what? Pi IA. IA constant, flux constant. Then torque is constant. That's why you can say this type of method is used for constant torque applications. Now come to output power. Output power is nothing but what? 2 pi nt by 60. So output power is proportional to n into t. Here speeds are what? Below rated speeds. Torque is speeds are decreasing, and the torque is what? Constant. So output power is finally what? Variable. So that's why you can say this type of method is used for variable output power applications. Finally, final conclusion, 3 points you have to remember from this method. This is used for below rated speeds, this type of method. And this type of method is used applicable for constant torque and variable output power applications. This is about armature resistance control method. Next method is what? Supply voltage variation. Supply voltage not remaining if you maintain constant means supply voltage increases, speed increases, supply voltage decreases, speed decreases. Support speed control methods of DC shunt motor. Now here I was given one note that field winding rheostat must be kept at zero resistance position only. If you kept at maximum resistance, depends on usage of rheostat. Rheostat, if you used double the resistance of field resistance is okay. If you use a very high resistor, what happen if you kept more means current flows to the field winding is very less. Field current is very less means what? Flux is also very less. If flux is very less, what speed of the motor increases very high. Means if the motor is running with a very high speed, maybe winding motor is designed to work for rated speed. If you increase the more than double speed, what happens is mechanical fittings, we fitted the motor by using bolts and nuts. Those are designed can withstand certain speeds only. If motor is running with more speed means high vibrations will come, so sometimes mechanical fittings may get damages. That's why we have to run the motor, we never has to run the motor more than the double more than the rated speed, more than the double value of rated speed, right? This is about a speed control of DC shunt motor.